Hello, pre-calculus students. We're now doing problem 2 in the packet. Billy watches a modeled by the function h of t, which stands for the height, is equal to negative 4.9 t squared plus 18t plus 57. I just want to clarify that here, h of t, that is equal to the height of the rocket and that t is equal to the time after launch. Launch. All right. So what is the initial height of the rocket? So that's going to be when t equals 0. So how do we find this? Let's use this problem in our calculator. So first we plug in the function negative 4.9. Our variable is t, but here we just put an x because that's the variable in the calculator. X squared plus 18x plus 57. Graph that. All right, so that is the function modeling a rocket. So what's the initial height of the rocket? Let's go to second table and know that when x equals 0, y1 is 57. So when t equals 0, h of t is equal to 57, and that 57 is going to be our answer. How long does it take for the rocket to reach its maximum height? So this is going to be how long does it take? That's going to be our t value. This is going to be our t value at a maximum. At the maximum, and the maximum is going to be the vertex of the parabola. So that's going to be the maximum at the parabola vertex. So how do we find that? Well, we take our calculator. Let's calculate that maximum. Second calc, maximum. We have our left bound point and our right bound point, and then we have our best guess. And our maximum is 1.83, 73.53. So that maximum, that x value is 1.836. So let's just do 1.84. So how long does it take? Our time is going to be equal to 1.84. And units are not specified, so units of time. What is the rocket's maximum height? Well, we just calculated our rocket's maximum height, and that's 73.53. So the maximum is going to be 73.53 units of distance. How long does it take for the rocket to hit the ground? Now that's going to be, the rocket hits the ground, look at my arrow, when its height is 0 after the launch. So we're going to have to calculate a 0. Calculate our 0. Move to our left bound point right here and our right bound point right here. Our best guess is right there at this 0. X is equal to 5.71 and our y is equal to 0. So x is equal to 5.71 and our y is equal to 0. So x is equal to, sorry, when, so we have coordinates of, we have a coordinate of 5.710. And notice our coordinate, x coordinate, is positive because it's after the launch takes place. So that's going to be 5.71 units of time. And what times is the rocket at a height of 68 feet? Well, to find this, what I will do is I will put a second equation at y2 equals 68, graph it, and so our original function is going to equal 68 when it intersects with the line y equals 68. So to find these values, I'm going to calculate some intersections. Calculate the intersect. Well, the first curve is here, the parabola. The second curve is that straight line. My guess is at the intersect. And I have an intersection of 0.774 and 68. So we have 0.774, 68. That's one intersection. Another intersection is going to be, take the calculator, find another intersection. The first curve is the parabola. The second curve is that line. My guess for the intersection is close. And then we also have an intersection at 2.89. Y is equal to 68. So that's approximately close to 2.9. So we have another intersection at 2.968. So when does the rocket have a height of 68 feet? I guess these units of distance, that's feet. 57 feet. We have times at 0.774 and 2.9 units of time. All right, that's our video for problem number 2 in our packet.